episode, in this lesson of techniques and applications of definite integration, we will be taking a look at this example to see in what ways can we use different methods in order to solve it. So, a quick look at this question, we do see a double integration. And double integration with the boundary with the integrand in your Cartesian coordinates. So, firstly, what is this boundary? Boundary is x minus 1 squared plus y squared is smaller or equals to 1. So what does this boundary looks like? So many of you might already know what is x squared plus y squared smaller or equals to 1, which we have the circle. So what will this circle look like? So let's say we have the x-axis here, and we have, whoops, a little too slanted, sorry about that. And we have y-axis over here. So this circle, what it will look like is, let's say, so x minus 1, that means its origin or its center will be at 1, 0, alright? So you'll have something like this. So a circle of radius 1 about the point 1, 0. And since it is smaller or equals to 1, that means you'll have whatever is inside of the circle. And this will be the boundary you'll be seeing. Alright, so now we know what this boundary looks like. Since it is a circle, what kind of coordinate would we prefer to use? Well, of course, we would prefer to use polar coordinates. Yeah, you can go and try to use Cartesian coordinates, but you can try it on your own. We'll not be using it here. Right, so polar coordinates. What are some of the things you have to take note of? X becomes r cosine theta, y becomes r sine theta, dx dy becomes r dr d theta. Alright, so x becomes r cosine theta and y becomes r sine theta. Alright, so this is what your integrand becomes, and as from what I said just now, dx dy becomes r dr d theta. So now we need to determine your range for r and theta. So theta would be simpler to determine. Since this circle is only in your first and fourth quadrant, that means you can go from negative half pi to positive half pi. Alright, so this is your range for theta. Now, r is the main problem over here. How are we going to determine what r is? So of course, r would start from 0, alright? R starts from 0. But how is r going to work? You have to, let's say, it goes until here. How do you determine its length? Now, you would need to know some of the properties within the circle, alright? So, when you have a diameter and a line in a circle, what would you think of? So, how about let's connect these 2 points. And if you know the property of this, that would be that this here is actually a right angle. So with this right angle, your theta is over here, and this will of course be your r, and your diameter is 2, since, well, the radius of a circle is the 1. So you know that this would be your right angle triangle. And how are you going to find r? So in this case, you have cosine theta is equal to r over 2. So that means you'll have r is equal to 2 cosine theta. Alright, so this is what you are going to see. So r here will be from 0 to 2 cosine theta, while theta is from negative half pi to positive half pi. And here we could start integrating, alright? Now we take a look at this. R extends from 0 to 2 cosine theta. And then with each of these straight lines from your origin, you power them up from a negative half pi to positive half pi. So that is how this is going to work. Now, we could put this r inside, and we'll see r cubed cosine theta sine theta plus r. Alright, so for now, we would take cosine theta and sine theta as constant when integrating with respect to r. That means r cubed becomes 1 over 4r to the power of 4, and then cosine theta sine theta, while r becomes 1 over 2r squared. And then of course you have to substitute r is equal to 0 and r is equal to 2 cosine theta. And this d theta. Okay, so we could substitute in both of these values now. But if you're aware, since both of them have a power of r, when you substitute r is equal to 0, it is essentially 0. So r to the power of 4, that means you have 2 to the power of 4 over 4. So that means you will have 4 cosine to the power of 5 theta sine theta. Well, for half r squared, it would be plus 2 cosine square theta. And this entire thing, d theta. Okay, so the first part would be simpler to solve, since you could put a sine theta into your d theta. Or for your second part, what you actually have to use is a double angle formula. Alright, so we would have to separate these two terms and work on them individually. So the first one, you can just take the 4 out. So 4, integrate from negative half pi to half pi, and cosine to the power of 5 theta d cosine theta. But since if you put it in, that means you have to be aware of an extra negative. Alright, so this is what you see for your first term. Now in your second term, since if you know the double angle formula for cosine, which will have cosine 2 theta is equal to 2 cosine square theta minus 1. So 2 cosine square theta is just cosine 2 theta plus 1, and then d theta. Alright, so this is what happens when you use your double angle formula. Now the first term, we could pretty much calculate it already, which you would be seeing negative, so 4 divided by 6 would be 2 over 3, and then cosine to the power of 6 theta, and you have to substitute theta is equal to negative half pi and theta is equal to half pi. While for your second term, again you could split it into two different terms, which for the first one you will see integrate from negative half pi to half pi cosine 2 theta d theta, while for your third term, that would be integral from negative half pi to half pi and then d theta. Okay, so let's take a look at your first term. Now in your first term, cosine pi over 2, oh, that's a 0. Cosine negative pi over 2, that's also a 0. So the first term just becomes a 0. Okay, so let's take a look at your second term. Second term, you could make whatever inside here become d2 theta. So d2 theta, that means you need an extra half. Since now you can integrate it, that means, well, you could just write this step by step still, or you could just immediately know that this is sine 2 theta. And of course, theta, you have to put in the values negative half pi and half pi. While for your last term, you're just going to have theta, and you plug in the values negative half pi to half pi. So let's take a look at your term for sine. Now you get a sine pi, which is a 0, and a sine negative pi, which is a 0. So the first term here, again, is a 0. And all you're left with is this theta term, which you have pi over 2 minus negative pi over 2, which gives you pi. Alright? So this is the answer for this question you have over here. Alright? So now let's take a look at what kind of methods we have used. Now firstly, of course, you have to know what kind of boundary you are dealing with. And once you know whatever boundary you have, you can then determine the coordinates, which in this case, it would be more simpler to use the polar coordinates. Now polar coordinates, using a property of the circle, which is your right angle triangle along your diameter of the circle. Alright? So, or you can also say a right angle triangle within a semicircle. Alright? So, afterwards, we pretty much just integrated, more integration, and then you put a sine into a d theta while using your double angle formula. And then the rest is just more integration and you finally get your answer. Alright, so I hope for this lesson, you're clear of whatever is here so far. So I'll be ending this lesson here, and thank you for your watching.